Today we will be interviewing Andy Maguire, our head of ML, and let's dive into the first question. What exactly do we mean by machine learning?
One way of thinking about machine learning is a sort of lazy way to write functions, basically, where instead of actually writing the code in the function, all the conditions as what you're going to do when and all these edge cases, machine learning is kind of replacing that function with a different type of function that just uses data plus algorithms to come up with those inputs and outputs, or come up with the outputs given the inputs. One way to think of it is similar, very similar to how we think of functions in programming, but actually it's kind of a lazy way to write a function, so you don't have to kind of do much thinking. All you need to do is figure out the data and algorithm you want to use and how you're going to, the types of data you're going to feed in and what the outputs are. You don't have to figure out the actual body of the function. The ML algorithm does that for you. And so that's where we get to kind of concepts of like, some of these algorithms, they are black box algorithms. It's not really clear. It's a little bit harder to understand what's actually going on inside the body of this ML function. There's different types of algorithms that are much more transparent and understandable. And then there's ones that are much harder to kind of reason about. So, but at the end of the day, you can think of machine learning as just like a sort of a Lego block or a lazy way to come up with these functions. All you need to do then is worry about the inputs and the outputs. And then you let the actual ML algorithm plus the data that it needs kind of do all the hard work under the hood.
So my next question would be, what is the state of machine learning in the observability, troubleshooting, and monitoring industry?
One of my hot takes is that we're actually quite far behind when it comes to machine learning and its adoption in the industry in general. It's kind of still deemed exciting, innovative, fancy. Whereas when if you compare it to other industries like advertising, finance, even tech in general, ML is much more just a normal tool that you use to its core, like a core part of the business. So like in advertising, click-through predictions of is like the core way that ads are presented on the screen to you. So ML is actually core to what they do. Likewise with finance, you have things like risk prediction models, you have churn prediction models. They're just, again, a central part of actually, the process of finance. Similar then, like technology in general, like recommendation engines are everywhere, And so when it comes to observability, it's kind of strange that we're still kind of just in the traditional approach of, here's collect some raw metrics, some fancy data engineering to get all these metrics or these logs. But at the end of the day, it's presented in a chart or visualization that's, that hasn't changed. It doesn't seem it's in the last 10 years or so. And so that's a good thing because it means I think ML is still very early on in its journey when it comes to observability. So it means there's lots of low hanging fruit. There's lots of quick wins. There's lots of sort of space to explore in terms of, what would be general ML use cases across the industry that are going to just become part of the normal way we do observability. The obvious one there being anomaly detection, being, an obvious first kind of cornerstone that we would use machine learning for. But there's lots of others as well in terms of how you navigate your data, how you actually visualize your data, how you surface the insights from all this raw data up to your eyeballs at the right moment in the right context. There's lots of different ways we could use ML as part of that whole UX basically. So there's still loads more work to be done, I think, when it comes to leveraging ML as another type of UX in observability.
So what are some trends, good and bad, that you see in our industry in the specific space that we are in?
Some bad trends I see is a lot of kind of companies sort of overselling the whole AI ops. But often when you look at it, it's it's really hard to even understand what is the machine learning or the actual AI. So it's kind of easy to play the game of the hype and the buzz and oversell things as AI ops. And so I see a lot of companies sort of doing that. And anytime I try and actually read their docs and get into detail to say, okay, well, actually, how did they frame this as a machine learning problem? What algorithms are they using? You're left kind of none the wiser. So I think that's a bad trend where people kind of sometimes oversell the machine learning, pretend like it's magic of some sort, because I think that just puts up these artificial barriers where people then don't actually feel like, end users don't actually feel like they can learn what the machine learning is doing or understand it. They just have to kind of blindly use these tools, and they don't really understand how the tool works. So they're not as well informed to understand like where it's going to be good, where it's going to be maybe not so good. One of the good things actually in the industry in general is that there's so many open standards, and open standards seems to be just natural in the observability space. So if you're looking at things like open telemetry and how different platforms interoperate with each other, there seems to be just by default the assumption is usually that you're going to have some sort of open standard or some sort of nice way for all these tools and platforms to play with each other, which is really, really good, because it means you can focus on one part of what you're specializing in and still play well with all the other different players in the space, because the observability ecosystem is kind of crazy. It gets bigger and bigger. You have this map of all the different players in it. It gets bigger every year. So it's good that we have, there's a natural tendency for, APIs to be really well thought out and well considered, and lots of just natural interoperability between players. There is some people doing machine learning in the space, being open about it, being transparent about it, having, open webinars, open docs, not trying to hide the details. And so there is a few companies that kind of the exception that prove the rule. So I like to when I see these companies, I like to try and follow them.
My last question for this interview would be, how is Netdata staying at the forefront of machine learning development?
We don't store all of users' metrics in our cloud, and so we don't have the luxury of a big cloud data store where we can just throw infinite compute and infinite, cloud costs at the problem and just throw the kitchen sink at it and then see what sticks. So we actually have to be much more kind of creative in how we frame the ML problems, which algorithms we choose, how we're going to implement it, which libraries we're going to use, various trade-offs between, how much overhead can we take on the agent versus would this particular ML feature live best as a cloud microservice, or so we have to kind of be a bit more creative in terms of how we frame the problem, the inputs and outputs, and also the types of algorithms we choose. And then of course the hardest part usually is the UX of all that as well. And so I think one of the things that actually has been kind of exciting for me to work on is actually that we don't have the luxury where I can just say, import latest hot model, open, whatever the sexy library is right now, and just blindly just kind of run it all through that. We have to be a bit more kind of grown up about it and a bit more creative about how we actually implement various things. And that's the hardest part of machine learning and data science, I think, is the creative part of it. How you can actually plug together all these different Lego blocks in a way that makes sense, in the sense that somebody has actually taken a step back and architected the whole system, as opposed to just trying whatever you can. And ideally what I'd love, what I really, really love is to have some sort of federated learning system where we can actually have all the ML happen as much as possible on the edge, but also then make sense of it all in a sort of a useful way that we can kind of make the most out of the data. So some aspects of what we're going to try and do is federated approach to how we do the ML, which will be interesting, because that just means then from by design there's no central kind of cloud bottleneck. The data doesn't have to be all centralized, and that just makes life a lot easier for users, because they don't have to nobody has to worry about these massive cloud bills. But it also means sometimes that actually we can kind of do more simple algorithms locally on the agent.
Thanks, Andy, for answering all these questions today. Head over to our Netdata blog to read more about machine learning and Netdata.